One of the things that I was talking about just a second ago was about fractions and how often we use them. And some people don't think we ever use fractions. I want you to stop for a second and think about the pages that you take your notes on in class and do your homework on. You know what the measurements are on those pages? 8.5 by 11. Now, I don't know why they didn't do 9 by 12, but they did 8.5 by 11. Now, any of you who might be working the building trades think, well, that doesn't apply to you. Do you know what the measurement of a 2 by 4 is? It sounds real nice, 2 by 4, but the measurement really is 1 3/4 by 3.5 or something like that. That's the reality, and I'm not sure but what everything that's measured would have fractions involved somewhere. I don't know if they're exact measurements in anything. Well, they probably are, but you can see what I'm saying is fractions are part of our reality, so we need to know how to deal with them. Now, I'm going to take an example of a fraction because I think this is one of the problems that people have. If I take this fraction, 4/9, and you look at it and you got to decide what it is, you might think, well, 4/9, that's the name of it. What does it mean? 4 out of 9. But how much detail do you really know when you see that fraction? I want to show you a way to look at fractions, and then I'll demonstrate to you how actually understanding this idea really does make it easier to work with fractions. Now, I'm going to draw a picture because I think when we can see things, it makes it a little bit easier. And you're going to have to use your imagination a little bit because I don't do this very well. I was lucky there, I came close. Now, you've got to look at this as some whole object. There are 9 parts, and when we talk about 4/9, we're talking about 9 equal pieces, and that's why I said you got to use your imagination because those obviously aren't equal. But when I talk about 4/9, I'm talking about 4 out of those 9. So when I look at a fraction, the bottom number here, which by the way they call the denominator, and I have to be honest with you, I'm not sure wherever they came up with that name. But that's what they called it, and we're kind of stuck with it. This denominator tells us what we're dealing with. So whenever I look at a fraction, so that I know what I'm dealing with, that's the first place I look. I look there to know what I'm dealing with. So when I look at this, I say, okay, I'm dealing with 9s. Now there's a little bit more that I need to know than that. I need to know, when I see that 9, that if I have something whole, whatever it is, that 9ths would be there are 9 equal parts. Now some of you may be able to think of it. Say I took a piece of a whole pie and I split it into 6 equal parts. Each one of those parts would be 1/6 of the pie. I don't use pies because I'm not very good with circles. I'm bad enough with rectangles. Circles, not so good. So I use rectangles, but this is what I see. So the bottom number, called the denominator, tells me what I'm dealing with. Now the top number, which they call the numerator, tells me how many of those I have. This one makes a little more sense to me. You know, we're talking about the number that I have, number, numerator. Can you kind of see that maybe that one works? The numerator tells us how many of those that we have. So the way we name them, you kind of have to know this, and I think probably you do whether you realize it or not. If there are 2 of them, they're called halves. I mean, you know that, right? If there are 3 of them, they're called thirds. Now, for most of the rest of them, you just put a TH on the end of after the number. So if I've got 4 of them, they're fourths. 5 of them, they're fifths. 6 of them, there are 6, and so on. So that's pretty easy. You should be able to remember that, and you do need to remember it. But there's an oddball group, and I think you'll understand why they do what they do when I say it to you. The 21, 31, 41, 51, 61, all those numbers, they don't put the TH on the end of it. But think about it for a second. 21st, 31st, 41st, 51st. I mean, you'd think somebody had a real bad speech impediment. So, like me, impediment. So what they do is they put an ST at the end of it. So it's 21st, 31st, 41st, and so on. So there's just a few rules you have to follow to be able to name fractions. And if you're going to talk about them, it's nice to be able to talk about them in a way that everybody knows. So if I see this fraction, 3/8, what I see, what my brain sees, or my eye sees and gives it to my brain, and my brain translates it, I'm dealing with 8ths, and I have 3 of them. That's what I see. And I'm going to demonstrate to you how understanding that idea makes working with fractions a whole lot simpler. 8ths, and there are 3 of them. Okay? Now, the first example that I'm going to give to you is when we add fractions that have the same denominator. For example, 1/9 plus 4/9. Now, first of all, when you add apples and apples, what do you get? Apples. Okay? You don't even get applesauce. You get apples. Well, what that helps me with is when I see here, I look at these two fractions that I'm adding, and they're both 9ths. So what am I going to get when I add? I'm going to get what I'm adding. I'm going to get 9ths, and that tells me right off the bat that I put that denominator over there. If you don't get that clear, what some people want to do is they look at that and they say they're adding, so 9 plus 9 should be 18. That's what they want to put there. But if you're adding 9ths, how can you get 18ths? There aren't any. You get what you add. Okay, so now, how many do we have here? 1. How many do we have here? 4. How many do we have all together? 5. Now, I didn't have to go to the math book and read the rule that says when you add two fractions that have the same denominator, the resulting denominator is going to have that same denominator, the resulting fraction is going to have that same denominator, and you get the numerator by adding the numerators together of the other two fractions. Gee. I'm adding 9, so I'm going to get 9. So I have 1 here, 4 here, there's 5. That's it. I'm done. Isn't that a whole lot simpler to be able to do that than what trying to follow the rule that they set in the math book? And the way some people, that's the way some people try to teach it. So learning that one idea about how to look at a fraction and tell what you're dealing with makes the whole thing a whole lot simpler. Now, it isn't all real simple, but that part of it at least is very much simpler. Okay, one other thing I want to show you, and that's when we convert mixed numbers to improper fractions. And we'll have to talk a little bit about those ideas. A mixed number. Why do they call a mixed number a mixed number? One of the things that you really want to learn when you're dealing with math is words mean what they mean. I know somehow we have in our mind that some alien race out in the deep dark recesses of space sent a spaceship to Earth expecting that it would blow up and this little thing they had in there containing math would leak out and spread throughout the world and drive everybody crazy. But that's not it. Words mean what they mean. So if you learn the words, if you can just get your brain convinced that the words mean what they mean, a lot of this stuff is really pretty simple because you already know it. Now, for example, mixed number. if I have this number, that's called a mixed number because I have a whole number, a 3, and I have a fraction. And they're mixed together. So that's a mixed number. That makes sense, doesn't it? Now, converting a mixed number to an improper fraction. What I see, because I've trained my brain to do this, what I see when I look at this is I say, oh, I'm dealing with 8s. Well, I look over here and I've got 3 whole numbers. And then I think, wait a minute, 8s, that means there are 8 in each one of those 3 whole numbers. So I've got 3 times 8. That's 24. And then I've got 5 of them here, because this is 5 eighths. So I've got the 24 that I have here in this full group of 3, and I've got 5 more of them there, so I've got 29 eighths. Now again, if you look in a math book, the math book will tell you to multiply the denominator times the whole number, then add the numerator together, make that a fraction with the original denominator, your denominator. That's kind of what it says. But it's not very clear, and if you understand the idea, you don't have to worry about that. Just as a sidelight right here, we'll talk about this more. The reason they call this an improper fraction, they think it's terrible that that poor little 8 should have to haul that big 29 around. That's terribly improper that that should happen. Well, I got news for him. That's a tough little guy here. He can handle that 29 with no problem at all. But they want to call it an improper fraction. That's okay. But you need to know something. There is a time when it really is improper to use something like this. If any of you cook at all, how many times have you ever seen a recipe that called for 15 halves of a cup of flour? Now think about that for a second. 15 halves of a cup of flour. Would you know what the world to do? I guess you'd get a little half cup out and you'd measure 15 of them. But if I got 7.5 cups, well, I just take 7 cups in and put a half in, I'm done. So there are some times when it makes more sense to use a mixed number than it does a fraction, but that's the only time that it really matters. Otherwise, 29 over 8 is just fine. Oh, there is one other improper fraction. That will always be improper, or anything like it. Why? Well, what's it equal to? How many times will 7 go into 7? Or how many times will any number go into itself? Always 1. As I said, this would always be considered an improper fraction because we would never write it like that because we always reduce fractions. And since any number divided by itself is 1, we would always write it as a 1 and not as a 7. So, this is basically how I like to approach teaching math. This is just an example, but this is what I want you to see. This is the kind of thing you can expect from what we're going to be doing. The kind of tutoring things we're going to have available. And if this looks like something that might be helpful for you, we would appreciate it if you'd come and check with us at our website, because we're going to have tutoring lessons on all different kinds of basic math. We're going to expand that eventually to include upper division math, statistics, and who knows whatever else. If there's something we don't have that you're interested in, if you'll let us know, we'll check into finding out how to do that. And we'll try always in the things we do to make it something that will be understanding and useful for you. So we're looking forward to hearing from you. We hope we can be of help to a lot of people. We hope you're going to be one of them, and that you'll find that this will be something that will be of great benefit to you, to eliminate the problems people have with math and be able to go on and say, hey man, I can do whatever I want because math is no longer ever going to be a problem for me. So we'll look forward to seeing you. Thanks for coming by.